Infrastructure is crumbling and the problems are only getting worse. The pressure to find solutions is hot. Let's talk about why American cities have no water, no electricity, and no money to fix their infrastructure problems. Welcome to the Infrastructure Hot Seat Podcast, hosted by Chad Smeltzer.
Hi, everyone. Welcome to the Infrastructure Network. My name is Chad Smeltzer. I am your host. Today's guest is Dr. Amir Alavi, who is the assistant professor at the University of Pittsburgh. Thanks for joining me, Amir.
Hello, Chad. Thank you for inviting me. Great to be here. We have a lot of interesting things to share and talk about, for sure.
Now, last time you and I spoke, we talked about your experience, how you got involved with metamaterials, and some of the things you were doing out in Pittsburgh, in Pennsylvania, as far as working with DOTs and stuff like that. We were talking about the tech. Ever since that, though, it's been almost a year, I think, right around a year at this point.
Yes.
Kind of give us an update of what's been going on and with you and the University of Pittsburgh.
Yes, actually a lot of things. So, when we had that discussion, that very nice discussion last year, I was talking about the fact that we are exploring this design space. We are exploring all of this cool stuff, metamaterials. And actually last year, we could have secured a number of projects. Getting projects is cool, specifically because now we can show people that these are really working out there. Okay. Just to give you an idea, we have one project with PennDOT. And that project is going to focus on developing lightweight and high performance metamaterial structures. And specifically, if I want to give you an idea, think of a bridge deck that is made of metamaterials. And this is the thing that we are really going to do for them. We are going to design metamaterial blocks that can be prefabricated, assembled, and create a bridge deck. In 5 years, if you see a bridge made of our metamaterials somewhere in Pennsylvania, just don't get surprised. It's there. And I'm really thankful to PennDOT and also our other partners, including Turnpike, because, they care for research. And the point is that they also bring a lot of expertise, practical expertise. So we are talking about how we can modify the geometry, how we can make it work, because we really want to see that somewhere in practice, somewhere on our infrastructure systems helping people.
Right. And we're dealing with so much infrastructure problems right now. Every day on the news, something that's going on with civil infrastructure, whether it's cyber risk now of people hacking our systems for utilities, water systems, stuff like that. Yeah. And then, bridges, right? All these are important assets that we have.
These are exactly, specifically for bridges, we are in Pittsburgh, we have 440 something bridges here. Okay. And it's not like in Pennsylvania, we have a lot of bridges, and many of them are aging structures. It's so expensive to replace them or reconstruct them or even maintain the performance of these bridges. So one of the things that I was talking with PennDOT and other partners is that we should also look for solutions that are less expensive. So when we are talking about lightweight structures, think of that as cement consumption or concrete consumption. So first of all, some of the designs that we are creating for them, it uses basically 30% less material, concrete, while giving you the same mechanical performance or similar performance. And now think about the fact that, there are a lot of articles that they clearly mention that 8% of carbon dioxide or carbon dioxide emissions are coming from concrete industry, and because of release. So think about the fact that we can basically reduce that carbon emission by 30% by designing this structure. So it's not just again a fancy game and nice cool designs or something. It's something that's really going to help people, and that's honestly something that I'm really passionate about at this moment, because we have done a lot, and now I really see that we can do something good with all of these structures. I really like that. So that's a good part about this effort.
That's exciting. It's so exciting, man. I love talking to you, getting an idea of what you're creating with these metamaterials and how they're really going to impact our future of all civil infrastructure, buildings, bridges, whatever
Chad,
that.
it's not
Go ahead.
only bridges and structures.
Okay.
So I'm always telling people what is really fascinating about metamaterials is the scalability. And
Okay.
like we have, I guess I told you before or not, but we are creating cardiac stents, tiny
Oh, wow.
nano size. We are creating esophagus stents. We are creating bridge decks. So when you come up with the unit cell that has that desired performance, you can
Yeah.
literally scale it down or scale it up. So
Mm.
people are always asking me, okay, as a civil engineering, what are you doing in biomedical engineering? I said, these are actually very related. We are talking about a material technology that is scalable. So
Yeah.
literally, the same structure that is deployed on a bridge deck, I can scale it down to work on artery, for example. And the same thing,
Wow.
we are using that for spinal fusion. So that's the thing. So when you come to my lab, hopefully I will have you in my lab. You can see we have a range of items. So that's probably one of the interesting things. So we are developing these actually structures for medical implants at the same time for many civil infrastructure systems. And I don't really have time to do more, but I wish I had, because think about the fact that you can use these structures for space applications. You can create a shuttle that is lightweight. You can create an aircraft which is lightweight. I mean, that's a lot for me to handle and to go after. But for now, we are really focused in this area, and I still to make time for me to work on all of these areas. But again, that's really cool that they are scalable. Very nice, very exciting to me at least.
That I remember you talking about nanotechnology last time we talked. Now you reminded me of that, and I didn't know exactly where that was going to go, but that
Yeah,
makes a lot of sense. Now you're talking about in medical field, the
yeah,
civil infrastructure world. These materials are so smart that we can
yes,
really use them in any application. It sounds like
yeah,
physical applications. It sounds like.
yes, exactly.
Um,
Physical
wow.
application.
That's huge. Now, you said before we started the podcast
Yeah,
that you were in the news article. Was it New York
yeah.
Times or something like that you mentioned?
Yes, it was New York Times. Yes, and that was really interesting. Because metamaterial in civil infrastructure systems is a growing field, and actually, we are leading that area, and I'm really happy about that. I can brag about that probably. And like we are working on two projects for PennDOT and Turnpike, and we are going to give
Okay.
them designs. And specifically, the Turnpike project, which we can get into that later, like they really want to see some of these prototypes out there on highways.
Right.
That's very serious stuff. So we should be able to see them like in 3 or 5 years from now. And
Yeah.
the problem is now, like I talk about all of the good stuff. Let me tell you what are the challenging part for us. So
Yeah.
again, if you remember, I said like these metamaterial structures are composed of some repeating unit cells or blocks, or okay,
Yep.
or repeating chunks of materials. You can assemble them in different forms to come up with any mechanical properties. For us, we also introduce some electrical properties, energy harvesting properties, which actually makes it more complicated. Now think about the fact that you have billions of potential designs for these units, these, let's call them blocks, to
Yep.
assemble them, to form them, to shape them. The question is that how can we do that manually? Like you and I can sit here and said, okay, Chad, this is a nice design, we can just do it. But I mean, how can we verify the performance? So the solution that we found was to use AI, artificial
Right.
intelligence. And in particular, we are using a very kind of recent branch of AI. It's called generative AI. I'm sure you have heard of that. So this generative
Yep.
AI actually is the engine underpinning ChatGPT and many of these recent like ChatGPT style search engines like Google Bard. So they are
Yeah.
generating new content because just to give you an idea about AI and generative AI, AI itself is learning whatever you are feeding it. So you
Yep.
can expect it to give you more. Generative AI generates content.
Right.
Now, how we use that for civil infrastructure systems and also for medical implants is that we have a tool that we are giving it some shapes, initial basic shapes like circle, square, whatever, and then we
Yeah.
define some objectives. I say, and we ask it, hey, go and find me a design that gives me the best compressive strength. give me a design that gives me the best shear modulus, the best buck modulus. It just
Wow.
goes and goes and it creates millions of unit cells, tests all of them, and at the end of this process, it gives you one unit cell. Actually, I have some of them here for you.
Yeah, yeah.
That unit cell is the key here. And we cannot really do it manually. That's the thing that when my PhD students, one of my PhD students, actually, they gave most all of the credit, like they were doing the hard work, and I really appreciate all of the hard work they were doing. So when she showed me one of our designs, I was like, wow, this is creation. This is the meaning of creation. And I have one of the designs.
Let's see it.
Here.
Let's see it.
So, for example, this is one of the designs created by AI. Okay, let me show it. And when you look at this, let me maybe, this is the camera. I mean, like, look at all of those complicated, intricate shapes. Okay, this is one thing. This is another one here. Let me show you. This is one. So these are optimized for different objective functions. We have, so these are polymer. We also created a concrete sample. Like this is, for example, one of them for PennDOT project composites. Like this sample is giving you the same performance as a solid piece of material, 20% less material, 30% less material, similar performance. So we are exploring, like in 1 week, we could have generated like 100,000 different unit cell designs. So it's kind of like becomes like a very problem-specific design for everything. And this story was very interesting for New York Times. So they dedicated a full story to this one because, when we talk about AI and generative AI, it's very cool and very useful because it helps us a lot, but it also brings up a lot of concerns like safeties. I don't know what is going to go. And the thing out there is that for civil infrastructure system, we are not really worried about the things that people are talking about, robots and how they are going to like destroy us or whatever. Because in civil, we are using them to create a structure. We test those structures with some standards that we have and done. We just verify them. It's just a very useful tool. Yeah.
So the images or the actual metamaterial that you just showed me would have the area to put electrodes inside those void spaces, it looks like, correct?
Yes. These are pure mechanical systems. Okay.
Mechanical.
So it means mechanical. So these are mechanical blocks. So what do you do, for example, for a block like this one? So this is one block unit cell. So you assemble them to shape any structure. So I assemble them periodically to create a bridge deck. I can scale this down to create a cardiac stent. Okay. So that's the point about that. So the other area that we are working and we are also leading that area is we call them composite metamaterials or composite mechanical metamaterials. So this is single material. They are multi-material systems. Why? Because you remember when you create these layers, you can generate electricity. Like we have these mechanisms. So now we are actually working on our algorithm to give us designs that are also optimal from a power density or energy generation perspective. So when you apply mechanical excitation, traffic loading, heart pumping, walking, spine loading, it generates a signal, but it's also mechanically optimized. So that's the thing that is like, it's a huge design space. And the thing that I just showed you there is single. Think about the fact that you're going to have different layers inside like this structure. This is going to be like a huge research area. And it's just the beginning, honestly. Like I'm telling people, it is just a scratch the surface. There are a lot of things.
Well, you're in such an early stage of transition. Now you mentioned about the projects you have going on right now.
Yes.
They obviously wouldn't just accept the material and put it out there and trust that it's going to work. You're going through the testing phase, the pilot project phase, of making sure that there's at least longevity there of it working the way you say it's working, right?
Yeah.
And then you're talking about generative AI, where now we have building information modeling, for example, this digital twin stuff that the technologies, we can literally sit down at a computer and build a structure in 2 hours, 2 to 3 hours, if you get the right data elements that you need to plug into the system. It'll create it, right? Just like you're talking about using GPT for, creating the designs, right?
Yes.
So if and I have a question coming for you. Once, you know, America's infrastructure and civil
Yeah.
engineering in its own and engineers on their own start getting the freedom to start using this technology,
Yes.
we should be able to streamline infrastructure in America in
Yeah.
months versus the years that it's taking now to actually
Yeah.
plan, design,
Yes,
and get these projects out
absolutely.
there. Yeah,
Absolutely.
curious in your thoughts.
I mean, this is actually a very good point. Like based on our experience, okay? So first of all, about these designs, okay? And it's very relevant to your question. So these are using a kind of evolutionary process. We call it evolutionary generative process, which simulates like natural evolution. So these samples, like these are based on simulation of that process. What we see, for example, for bone, you see it has a very kind of weird structure, but it's been optimized over billions of years. So we could
Yeah.
have reduced that evolution process from 1 billion years to 3 days, okay, for design.
Wow.
So now with this generative AI tool, and now to your question, I mean, that's the same thing. Like, think about the fact that you are feeding a generative AI tool a lot of information. Now it can give you a lot of interesting decisions for your infrastructure systems. Like you can give it the design structure. You can actually ask it, hey, just go ahead and design me a bridge structure that is efficient, like from like earthquake perspective, earthquake resistance. So I mean, again, this is just the beginning, I believe. And we have a colleague here at Pitt. They are actually using this generative AI tool, another type of generative AI tool, to help our construction workers, our safety workers, to come up with solutions for the problems that they have. Okay. And
Right.
again, for decision making, this is very important. Like in civil engineering, hard part, like mechanical part, we just test them, we are sure. But if you're going to use that for other areas, it needs to be validated at multiple levels. You cannot just use it without, because think about the fact, yeah, like it's giving you, hey, just we are gonna have to modify this part or something. You really cannot easily trust
Right.
it unless it's very much valid. But it's going to make our lives much more easier. I'm telling you, like I'm sure about that. Much
And
more
let's
easy.
think about it. Once we get the funding, that we
Yes.
need to build this infrastructure, we're gonna have which I feel that we're gonna get funding. We have to get funding. It's the only thing
Yes.
that
Yeah,
is holding
absolutely.
America back as far as civil
Yes.
infrastructure goes is funding. So once we get that funding, using these generative AI tools and these metamaterials and things like that in the future is going to be key to really monitoring our systems at that point
Yes.
and making sure that
Yes.
the maintenance is done correctly on these facilities and there's no deterioration,
Yes.
how fast it's deteriorating. Yeah, go ahead. I know you want to say something.
Yes, exactly. No, that's good. You need, so if you create like the digital twin that you mentioned is actually very interesting. So we have a project with Turner Park, one of my colleagues is leading that. So there we are going to like they are going to design a twin model of a piece of highway. So you are basically collecting a lot of sensor data. You have a smart infrastructure. That's the point. Okay, you have to instrument your structure, whether with smart metamaterial or with sensing system. Now you all have this digital twin of your structure. At any time, you can see what's going on with your structure. You are feeding the data to a making system based on AI or generative AI, and it processes the
Mhm.
data and it gives you some nice idea. This is like literally again speeding up the process, the decision making, speeding up and the process for making those fundamental decisions how to deal with this deteriorating infrastructure system. So it's going to really facilitate a lot of things for us. And I guess again, yeah, we need to. I think the governments, I guess, they need to like allocate a specific funding to this area, like because when you promote that, people start thinking about that, and then they can come up with a lot of interesting ideas, like the one that I mentioned with my colleague that they are doing that for construction workers. But
Right.
that's going to be the future for sure.
I'm so pumped up for it. I can't wait because we need it. We really do. We're
Yes,
wasting
yes,
so much time and money and effort just
yeah,
trying to traditionally build infrastructure.
exactly. Yes,
And we're seeing that even through our processes that we're not getting the best materials. I can tell you that firsthand. We're running into, pipe failures that are, supposed to last 100 years. They're not even making it to 20 years, right? There's even some
Yeah.
rehabilitation projects and things like that. They're just not even living,
Yeah.
like staying underground or staying in the air as long as they should be. So
Yeah.
with that being said, what is, everything sounds great. There's
Yeah.
all kinds of positivity with the metamaterials, but what are some of your challenges?
Oh, so a very nice point, actually. One of our main challenges. So we don't have really. So the main challenge, if you're asking me on the pure mechanical part, is fabrication challenge.
Okay.
Okay. I'm talking about the research aspects, because the designs, for example, that I showed you, they are not easy to fabricate.
Right.
And so you can cast them, you can 3D print them, but it's not easy. So that's the thing that
Okay.
we are also going to like provide guidelines for our partners. And I want to
Okay.
also thank our iRise Center. iRise is a center located at the University of Pittsburgh, and unlike PennDOT and Turnpike and Michael Baker and Allegheny and a bunch of other partners are really helping to promote research with that center. And these projects are processed through iRise. So what iRise is really focused is to give guidelines to PennDOT and Turnpike and again all of our partners to how to implement that. And speaking of implementing, so now think about the fact that we are giving them a design, but we need to really work with contractors to design these things. So we are always
Right.
trying to solve that problem with bringing contractors, experts in fabrication, to give us an idea of what is the best scenario, what is the best strategy to basically fabricate. So that's one thing about fabrication. That's a thing that I'm always thinking, and I'm always like, we can always do that in lab, but at larger scale, that's something. On the
Right.
multi-material system that they generate electricity and they can harvest energy and they can communicate, the problem is multi-material printing or multi-material fabrication. Because think about the fact that how can you put all of these different layers one after each other to create, it's one of the major challenges that we are going to actually work on proposal specifically dedicated to multi-material printing for the materials. And that's one of the things that, I mean, for me, it's a huge challenge. There are, of course, some regulatory issues on how you can use them, but again, it's the process. You're going to have to go through that. So I'm not really worried about that.
Yeah. Those challenges seem like that you'll be able to overcome them at some point in time with
Yeah.
the 3D printing. Once they start scaling those systems faster and make bigger facilities to house them, I would assume
Yeah,
you'll be able to
exactly.
fabricate faster.
No,
What I
actually,
was going to ask next.
we have concrete 3D printers in our labs. So we are 3D printing concrete. It's actually
Okay.
it's easy to work with it. Even you can design many of these
Okay.
intricate structures with it. So that can help a lot. And the concrete 3D basic technology is growing pretty fast.
Okay.
But the multi-material is a huge challenge. It's a huge challenge.
I'm sure.
Yeah.
What
But
do
again,
the
this is research
contractors?
we are doing. Yeah, go ahead.
I was going to say, what do the contractors think about this?
So the contractors first are very fascinated, like the ones that I'm talking. Like for Turnpike, I guess I didn't tell you. So we are developing metamaterial structures or walls that they absorb noise, like they can capture noise by design. Okay. So the same structure that I said,
Wow.
it works for bridge deck. If we ask our AI algorithm to give me a block that captures or traps sound, it can do that. And this is an ongoing project with Turnpike. So, and then again, you will have a noise wall which is 30% less heavy than a solid piece of concrete, and actually it can also absorb like sound. And then, for example, we are talking with contractors because they are actually, that they are putting poles and then they're putting some concrete elements of concrete, and so that's a part of our conversation with them to how we can do that. But again, I guess like based on their feedback so far, casting is seems to be like the best option. You cannot really 3D print many of these structures. 3D printing needs to be but casting is once you have, think of this, once you have a mold for one of these unit cells or these blocks, I mean, you're done, okay? And when you come up with this,
Right.
But again, that's also a huge concern. It was a huge concern with them for them. Now we are talking with them, but they're passionate, and
Okay.
I understand sometimes when you're talking about material consumption, so that would be a good thing for us and for contractors, but also many of the manufacturers like concrete production factories or other, they're also now very happy about like these type of sustainable solutions, because PennDOT and DOTs and US DOT, they're pushing for sustainable solutions, and they are encouraging people to do that.
Right.
So, and they are like the main consumers of that. So when you are going after sustainable solutions, you will be like like one of the best, basically, say, partners for these major agencies. So they are also like, I know a lot of these major concrete companies that they are really uh, putting a lot of efforts into sustainable solutions, sustainable concrete, and I'm really impressed by that. It's just nice to see how everyone is pushing for that part.
That's awesome, man. I love what you're doing there with the metamaterials and the scalability of it, to be able to use it in not just civil infrastructure, but basically a lot of physical assets that are going to be out there, that even in your body, so to speak. So it's amazing technology, and definitely go ahead.
I mean, you said,
You're going to say something.
you said embody. So this is cool. This is really cool, because, when things are going to be implanted in vivo, it's going to be super complicated. But the good point, the good news that we got recently, that is that we actually granted an NIH award, in which we are going to implement our fusion cages, our like spinal implants, in vivo for the first time in animal models. So we are going to, and this is actually the first time a metamaterial implant is going to be tested in vivo, and that's a nice thing about that. Yeah, it's really interesting.
That's so cool.
It's really interesting. Again, and I'm very thankful also to NIH for supporting this effort. But I'm really happy about that, because I really can see that sometimes in helping people.
Yeah. Well, it all comes down to helping people. That's what we're trying to do, right? That's why we're building. You're building metamaterials to help people and help civil infrastructure, help communities, right? It's our future. It's our kids' future.
Absolutely.
Making a big difference.
Yes.
Yeah. Well, Amir, we're out of time. It went fast as usual.
Yeah.
But is there anything that you need, that maybe someone's listening to, that they could reach out to you, that you need? Is there anything you need in particular?
Again, if anyone is interested in deploying and developing metamaterial structures, whether it's civil infrastructure systems or if a medical implant, we will be more than happy to have a conversation with them and explore the opportunities. We are actually from a development stage at a good stage. Like so when you're testing, for example, an implant in vivo, it means that you are in good shape, like you are already ahead of the schedule. So if anyone interested to know what is the mechanism, how they can do that for the specific applications, we are also open to any discussion. And for people who are decision makers, I would like to say that this is a growing field. It needs a lot of support. I'm blessed. I'm really blessed to work here and with all of these people supporting me, but probably we need to expand it across the nation, because the future of many of these material structures belongs to metamaterial structures. Like I can really see that. So maybe they can also push for that part. I'm good for now. I'm just telling for other people, okay? I have all the support that I want. So I guess that's it, Chad.
Awesome. Well, thank you so much, Amir, for joining the show again for the second time. It's been a year, so I look forward to following up with you in another 12 months.
Absolutely.
It flies by.
It's always great talking to you, Chad. It's always great. Yes, and I will keep you posted on what we are doing for sure.
Love it, man. Well, thank you for being here, and you have a great day.
Thank you. You too. Thank you. Have a good one.
All right, my man.
Thank you for listening to the Infrastructure Hot Seat Podcast. We hope that this show brought you some insight on relevant topics within the infrastructure world. Please join us every 2 weeks on Tuesday for the next episode. If you're interested in being a guest on this podcast, please set up a 15-minute interview with your host at calendly.com/Chad Smeltzer.